Okay, so the first one, pretty straightforward. We have x plus 3 must be greater than or equal to 0. I'm going to subtract 3 from both sides. Right. And you'll end up with x is greater than or equal to negative 3, which means that my domain will be from negative 3 to infinity. Good. Next one, we have 2x minus 1 must be greater than or equal to 0. So here I'm going to do a couple things. So I'm going to draw my little line here so I have it. First I'm going to add 1 to both sides. So then we'll end up with 2x is greater than or equal to 1. And now I'm going to divide both sides by 2. So then we have x is greater than or equal to 1/2. Which means that my domain would be from 1/2 to infinity. All right, the next one, remember it's cube root. So this is the S-shaped, right? So this means that it's just from negative infinity to positive infinity. You don't have to do anything for the domain. It's always going to be, all those S's, all those cube roots are always going to be our real numbers, domain and range. This one, this fellow over here, we've got 3 minus x is greater than or equal to 0. And remember I said to just add x to both sides. That'd be the easiest way of doing it. If not, you could have done it the kind of standard way, subtract 3 from both sides. So then you end up with negative x is greater than or equal to negative 3.
Yeah.
Now I'm going to divide both sides by negative 1. Or multiply, we can multiply both sides by negative 1. Do that. But here's the deal. As soon as we do that, we need to change the sign. I'll show you folks why in a second. So here we'd end up with x is less than or equal to 3. So those of you who just added x to both sides, this is what you got right off, right? It was probably written backwards. It's probably written as 3 is greater than or equal to x, but that's what you got. The thing is, whenever we multiply or divide by a negative number, both sides by negative number, what was greater with an inequality, they swap. The one that was bigger becomes smaller. So for example, let's look at an example. I have 5. 5 is greater than 2. Everybody agree with me? Here's the thing. If I multiply both sides by negative 1, now I get negative 5 and negative 2. Negative 2 is greater than negative 5. So whenever you multiply both sides, and whenever inequality, and multiply both sides by a negative number or divide by a negative number, the one that was bigger becomes smaller. Why is that? Think of it this way. Here's my number line. Here is 2. Here's 5. When I multiply by negative 1, it goes to the opposite side. So this one was ahead so think like this. Here's 0, here's 2, and here's 5. If I multiply by negative 1, all of a sudden, this one's further below. It jumps further back the other direction, so it becomes more negative. So now this one is ahead. This one's larger. Do you see what's going on? Right? It's jumping back more. This is jumping back less. So whenever you multiply or divide by a negative number, when they're not equal, when there's an inequality, the one that was bigger becomes smaller because it becomes more on the other side. So that's why, so I'll say it here. In an inequality, this only applies to inequalities. Oops. For inequality, in other words, when you have this, right, then multiplying or dividing by a negative switches the inequality. So this one becomes right. So this one goes to that one, or it's that one, it becomes this one. All right, so this one becomes that we have to switch it. Does that make sense for folks? I didn't want to really go there with this. That's why I said just add. But here, if we multiply by -1 both sides, then all of a sudden, this instead of being greater than, this one becomes less than. You got to switch the symbol, which is exactly what you got if you just added x to both sides. It's rewritten the other way, right? 3 is bigger than x. X is less than 3. Either way, 3 is the larger one. So how do we write this inequality? We write it as x is x is less than 3, so it becomes negative infinity to 3, like that instead. So that's how it impacts us. And then down here, again we have it's even, so this still applies. We're going to draw my little down the middle. We're going to add 5 to both sides. So then we get 3x greater than or equal to 5. And we're going to divide both sides by 3. So then you end up with x is greater than or equal to 5/3. So then the inequality will end up being 5/3 to infinity. And then this last one, all right, so x squared plus 1 is greater than or equal to 0. Subtract 1 from both sides. X squared is greater than or equal to -1. But here's the deal. X squared, what's the smallest x squared can be? Let's try some stuff. Let's try a really big number. Everyone try, 100 squared. Everyone try 100 squared. Okay, that's big. So that's a large number. Okay, how about -100 squared? If I did -100 squared, would I get negative a really big number?
Because the thing my phone said, keep it real.
Oh, whoops. So if I squared a negative number, let's try this. Let's just try a couple examples. So let's try that's funny. No. There we go. All right, we'll try 100 squared is a big number. So that doesn't really get me anywhere. I'm trying to find how small this can be. So then if I do -100 squared, I still get a big positive number. So what if I do,
still get 10,000.
yeah, what if I did 1 squared? I get 1. -1 squared, I get 1. So no matter what I do, I can't get to a negative number.
So it would be a 9.
Yeah, so well, no. What's the smallest x can be? What's the smallest x I can, well, okay, so x can be negative. I tried a large negative number, that didn't help me. What about 0?
0.
0 squared? So the smallest x squared will ever be is 0. So is there any x I can find where this will not be true? Will x squared be larger than negative 1? It can be anything. X can be anything. Because any x squared is going to be larger than, it's going to be greater than or equal to 0 even. So it's definitely going to be greater than negative 1. Does everyone understand what I'm saying? So, in other words, this will always be true no matter what x you give it. Right? I tried big x's, I tried really small x's, and no matter what I did, I always got a number that was greater than negative 1. So this means that this is really all x can be any number at all, because it will always be true. Good? Do folks understand why? No matter what x is, x squared is always going to be larger than negative 1. So no matter what I do, x squared is always going to be 0 or bigger, 0 or positive. So it's always going to be bigger than negative 1, always.
So why do we have negative infinity?
Because x can be negative infinity. Negative infinity, if you square it, is bigger than negative 1.
Bigger than negative 1.
Right? When you square it, it's always going to be bigger than negative 1. So there's no number, if I took negative infinity and squared it, it'd become positive extra infinity, right? That's going to be bigger than negative 1. So this is saying x squared has to be larger than negative 1. When is that true? Always. There's no x you can give me that when I square it, it won't be larger than negative 1. Because any x you give me when I square it will become positive, or 0, which will always be equal to or negative, greater than negative 1. Okay, so let's take a look at our next handout.
Negative infinity is positive infinity or negative infinity is
The
1?
positive infinity, yes.
So not-
All real
not
numbers.
1.
All real numbers. Does that make sense? Any number.
It's
We
okay.
don't have this.
We can talk about later.
I don't have that number, but we have it there.
Yes. So let me hand this out now. So I'll give folks one last take a picture now. That part there? Just that part there or the whole thing?
There. Thank you.
You're welcome. Okay, so we're going to start in on this part here. These are the rules about exponents. There's a bunch of rules that we need to go over that you need to understand. We've gone over some of them already, but I just want to review them with us before we get started with this, with things. So the first one is the product rule. Product rule. This one says that if I have a to the m, if I have the same base with exponents, you just add their exponents. So for example, 3 to the 4th times 3 to the 2nd. Well, 3 to the 4th is 3 times 3 times 3 times 3, right? Times 3 to the 2nd times 3 times 3. Well, what is that? It's 3 multiplied by itself how many times? 6 times. So it's the same thing as 3, right? 3 to the, so that's why 3 to the 4th times